All right, so what we're going to do is we're going to use that Desmos program, and let me get back to this, and we're going to put some stuff in. Tell you what, before we do the greatest integer function thing, let's just do some, quote, regular functions, okay? I guess the greatest integer could be considered regular, but ones that are a little bit more familiar. And what we're going to do, we talked about yesterday, if we put like a plus or minus inside of the function itself, that moves it left or right, okay? If it's a plus, it moves it where? To the right. No, if it's plus, it moves it to the left if it's inside the function itself. Okay, if your plus or minus is outside the function, what does it do to the function? It moves it up and down. If it's a plus on the outside of the function, it moves it up. If it's minus, it moves it down. Everybody got that? So if your plus or minus is inside the function, it moves it the opposite direction that you would think, right? If it's a plus inside, it moves it to the left. If it's a minus inside, it moves it to the right. So let's just put some of those in here and let's see what it actually looks like, and we'll compare it to the original one. So let's just use an x squared function. That's an easy one. It's a parabola. It's pretty easy to see. So let's put that in there. So y equals x squared. Okay, so that's our, what they call a parent function, or our basic one, our starting point kind of function. So let's mess around with this a little bit. Let's do some of the stuff we did yesterday, all right, and see what it does to it. You should know what it does, but let's just see. So tell you what, just gonna copy that and paste that right there. And watch what I'm gonna do. I'm gonna put this inside the function. So what if I put x minus, I don't know, 3, but I want to put that in parentheses. See what it did? So that's the blue one. See how that blue matches up with that blue right there? So what did it do? It moved it what? It moved it to the right, even though that's a minus. Because remember what the function is. It's x minus h, right? So it's minus however far. So it's minus a positive 3. Does that make sense? So the function itself, or the formula or the equation, it's x minus something. And so whatever is here, if it's minus 3, that means we move it to the right 3 places. It's minus a positive 3. So it kind of is a positive, isn't it, when you look at it? Does that make sense? So let's do another one. Let's copy that, put that here, and let's change this to a plus. See what it did? The green one took the original one and just moved it to the left 3 places. We already know that, but it's nice to see it visually, and we can do it super quick, all right? What if, let's go back to the blue one. Tell you what, let's hide that one. We'll keep the red one right where it is. And let's go to the blue one and put a plus, let's not go too far, let's just go plus 2. So what do you think that's going to do to the blue one? It's going to make it go up 2. So look what it did. This went to the right 3 and up 2. So really that point is where? It's at 3, 2. Everybody see that? So you could always tell the vertex. Just by looking at the equation, you can just look at this and say, what is the vertex? It's 3, 2. Does it make sense? Let's do it the other way. Let's go plus and then minus. So if I go plus and then minus, all right, let's see what that looks like. And, whoops, there we go. Did it change like how wide it is or how skinny it is? No, it didn't, okay? It didn't change the shape, it didn't twist it, it didn't do anything. It's exactly that red one, except I just picked it up and just moved it down here. Now again, where are we? We're at -3, -2, all right? So if I click on there it is right there, -3, -2. That's kind of easy. That's just kind of review from what we did yesterday. Not that big of a deal. So let's do something a little different. So let's get rid of that one. Let's get rid of this one. And I'm going to copy that one again, put it right here. All right, so that one's just right on top of it. But what if we put a number out in front of that 2? Okay, let's see what happens. So I'm going to put a 2. Let's just put a 2, make it kind of an easy number. What if I put a 2 right there? Let's see what it does to that purple one. See, you would have thought that it makes it wider, wouldn't you? But it actually makes it skinnier. Why does it do that? Because if I, instead of going up 1 or over 1, up 1, what's it going to do? It's going to go over 1 and up 2. So it makes it steeper, doesn't it? All right. So again, at first, I just let you say it made it wider because that's what I would have thought initially, right? It just kind of looks like, oh, if I put a 2 in front of it, it just makes it wider. But it doesn't. It actually makes it skinnier, okay? Let's do something else. Instead of putting a 2, let's put a minus in front of it. What do you think putting a negative in front of that x is going to do? It's going to flip it. That's right. It's going to flip it. So let's put a negative right there. Bam. There it is. We flipped it. Everybody see that? See, that's why it's nice to have this Desmos, just because it's easy. You know, you don't have to like put all the numbers in, make a table and all that kind of stuff. You just punch the numbers in, boom, you see it, just like that. All right, let's do this. Obviously, if we put a negative 2, what do you think that's going to do? It's going to flip it and make it skinnier, right? Yeah, make it steeper, skinnier, however you want to say it. Everybody see that? Now, what happens if I put a 3 in there? It'd make it even skinnier. Do you see what it's doing? All right, and I could keep going. Let's just put some ridiculous number, 10. See, it makes it really skinny. We good? And then if we made it positive, just makes it go up that way. And we could always put an x minus 3 inside of it, right? Squared, and a plus 2 at the outside of it. Moves it to the right, moves it up. You understand that. Okay, how do we make it wider? What's that number right now in front of it? A 1, right? A decimal, okay? Or a fraction, right? If it's between 0 and 1, it's going to make it what? It's going to make it wider. Because again, instead of going over 1, up 1, it's going to go over 1, up what? A half. And do you see how it's going to make it wider? If my first point is like right there. All right, so let's do that. Let's put in a half. I think I can do this. 1 divided by, nope. 1 divided by 2. Does that work? No, it doesn't. Let's just, oh, it's the other one. Oh, that's right there. Yeah, there we go. 1 over 2. There we go. See the purple one? So it's wider than the original one, all right, if we put a half. Now, if we make that number bigger, it's actually making the fraction smaller, but if we make the denominator bigger, I don't know, let's just go 5. What do you think that's going to do? It's going to make it even wider. See that? Okay? So it's between 0 and 1, because if we put a negative, negative is less than 1, that's for sure, but what is the negative really doing, though? It's just flipping it, right? It's not changing how wide the thing is. Does that make sense? So if you put numbers out in front that are between 0 and 1, right, they're decimals or fractions, and it's going to make it wider. If I put numbers that are bigger than 1, right, it's going to make it skinnier. We good? And that works with any kind of graph. So let's do an x cubed. Oops, I knew that was going to happen. Let's do this. Hit this to the third. Boom. Oops. Didn't erase the 2. Let's try that. There we go. Oh, it's way up there. What's going on? Now it should work. Let's see. Yeah, there we go. All right, so let's get rid of that. So there's our parent function. There's our y cubed graph. We're used to that, aren't we? Okay. Again, I'm not going to put all the minus things and the plus things in there, because you know if you put it inside the cubed, right? If I go like x plus 4 parentheses cubed, what's that going to give me? That's going to move it to the left 4 places, all right? Let's just see what it looks like when we put these numbers. Now, if I put a negative there, I'll tell you what, let's do this. Let's keep the parent function there. Let's copy it. Let's put this here, all right? And let's put a negative out in front. What do you think it's going to do to this? Yeah, it's going to flip it. So this is going to go where? It's going to go down like this, and this is going to go up like that. So let's see what it does. Boom. Yep. Just like we thought. See that? So the black one is our new one. The red one is the original one. Okay? What if we put let's go back to positive. What if we put a 2 in front of it? Okay, it's going to make it closer to the y-axis. That's a good way of looking at it. It's going to make it skinnier, isn't it? All right, so let's put a 2 in front of it and see what it does. There it goes. See, the black one is the new one, right? The red one's the original. And if you want to keep putting numbers in, let's go 5. See, it's making it steeper and steeper and steeper, okay? I don't know, let's go crazy, put 100. All right, there you go. All right. Get the idea? Yeah, same kind of thing. All right. What if we put a number between 0 and 1? Let's just do half again. So half, there it is. Again, the black one is the new one. The red one's the original one. And so it goes wider and wider. And just so we're clear on this, let's put a 1/6. All right, just keeps on making it wider. The shape is the same. Now, what if I wanted to move this to the left and right? Let's do one now. So, oops, let's put a parentheses right there, and let's put, I don't know, which way do you want to go? Nobody say anything? All right, let's go -5, and then parentheses, and then at the end of this, see what it did? It moved it to the right 5 places, and I don't know, let's go -3. All right, and there it is, right there. There's the origin, right? That's where it starts, goes here, and it goes down here. What do? We moved it to the right 5, we moved it down 3, and we made it wider, 6 times wider, basically, okay? If you didn't want it wider, you wanted it skinnier, what would you do? Put a 2 in there, and it makes it skinnier than the original. All right. Now, the part that I have not practiced, and the part that I think I did it last year, but I had to look it up too. So, Hunter, I'm going to need your help on this one. We want to do one of those greatest integer ones. Let's zoom this in just a little bit. There we go. Now, on Desmos, it's not intuitive on what you're going to put in here. So help me out, Hunter. We wrote it down. It's y equals a. Oops, I'm sorry. Oh, is that an asterisk? I thought it was asterisk. That looks like a plus, but that is an asterisk. All right, floor. Parentheses. I don't know if that. Oh, you know what? Because we need to put actual numbers in here. That's why it's not going to work. So.
It'll give you sliding.
It will? Okay. So let's keep going. What is it? B?
Parentheses.
Yeah.
X minus H.
X minus H. Close parentheses. Okay.
One more parentheses.
Okay.
Plus K.
Plus K. All right. Oh, there's a slider. So this allows you to change the A, right? Right now it's just a 1. But we could. What do we have to do? Like I said, I haven't done this, and I should have practiced this before I came in here today, so sorry about that. Yeah, I probably got to do. Yeah, there we go. All right, so let's make the H like that. Oh, there's the steps. I see them now. Do you? All right, and then the K, we'll just make it go up a little bit. See what it just did? So that H moved it 1.4. I tell you what, let's just go whole numbers, and then we'll go 2. There we go. Now let's see if I zoom up. Yeah, it doesn't really show me like open circle, closed circle, does it? But what do we always start with? We start with this closed, and then this would be what? Open, and then it jumps up to the next integer. I'm zoomed in a lot, so it's a lot of jumping. So there's my 1, and it jumps up to here, and it goes to the next integer. And you can actually hover over this and see it doesn't really go to 2. See that? I'm moving it to the right. It doesn't go to 2 because that means it's open there, right? But when you actually hit 2, let's zoom out a little, when you hit 2, it comes up to here. Does that make sense? And so it actually does show the number 2 right there. And if you go over here, all the way to the right, see it goes to 2 point, I can keep going. You see that? And then if I go just a little bit more, what's it do? Boom, it jumps up to that. So that's kind of cool, right? Shows a step function. All right. What about the A, though? What's that going to do? Well, let's just see. Can I just type in a number here? Yeah, let's put a 2. Oh, look what it did. It actually spread it out, didn't it? Okay, so instead of going to the next integer and jumping up 1, what did it do? You went to the next integer and jumped up 2. You get that? So it actually spread it out a little bit when that's positive. Let's put in a half for that. Ooh, look what it did. Kind of squished everything. Make sense? All right, so that's what it's doing. So the stuff that I'm showing you right now is the stuff that they're asking on those problems from the homework. But they don't even ask you to graph it, do they? Did you read the assignment? What does it say? It says describe. So if you see this x minus 2, what's your description? You're moving the graph to the right 2 places. Okay, and what does the k represent? That's a 2 as well, but that means you're moving it what? Up 2 places, okay? And then the a, what does that represent? That represents, I don't know what the word is. Do they have, did you look in the book? What is it? Expansion, is that the word they use? Okay, yeah, that's what I had in my notes, okay? So it expands it by a power of 2, right? Or compresses it, right? So the 1/2 would be a compressed. Do you see what the 1/2 does? It compresses it. Does that make sense? All right, so that's kind of what they're asking, right? They're not even asking you to graph it. You don't even have to graph it. All you got to do is just describe what those things are doing to it, okay? So that's kind of nice. Let's do this. Let's put a couple other functions in here just to play around with it. And that's what's cool about this Desmos. Let's see, get rid of all these. Again, I'm not a pro at this. There's so much more. If you go to YouTube, and I've done that, and what I really need to do is go to YouTube and see all the stuff that Desmos can do and then practice it. I've watched the videos, I just haven't gone and practiced it just because I got a million other things going on in my life. So, but it might be good for you to go to this. And this is a great tool to use. And I got it on my phone, right? I got it on my computer. It's just a website. You just go to desmos.com. Okay, that's it. Just desmos.com, and you can go to it and do the same exact thing that I'm doing. You could, it's an app on the phone. It's free, right? Doesn't take up much space. Acts really nice and quick. It's right on there. What's that? Do they let you use Desmos? Do they really? Wow, that's interesting. So there you go. So it's a good idea to get Desmos on your phone so that you know how to use it, and at least you're familiar with it a little bit. Because if they let you use it on the SAT, that's awesome. Okay, definitely use it. Yeah, well, back when I took the SAT, there was no phones, there was no computers, there was no anything like that. We had calculators, but that was it. That was about the most we had. And back then, I don't even think they let us use calculators when I took the SAT. But anyway, there you go. Let's do it. Probably wasn't that good. I don't remember what it was. It was very average, very average. Like I said, I've told you before, I'm not really like a mathematician. I'm just a guy that teaches math, you know? And so, but I enjoy math. And I think that's why I keep teaching, because I kind of enjoy it. I like learning new stuff. But I was never like super good at math. I was never terrible at it, but I was kind of mediocre, to tell you the truth. I probably would have never been in a pre-calc class. The highest math I ever had, this is terrible. You're probably thinking, oh my gosh, who we learned from? When I was in high school, the highest math I ever had in high school was Algebra 2. You believe that? And then I went to college, and I did take a pre-calc class. My very first class in college was pre-calc, even though I was a math major. But then I got into calculus, and calculus was kind of fun. I kind of enjoyed calculus. It wasn't near as hard as I thought it would be. I always had it built up in my head like calculus was going to be super hard. But really, it was just an extension of everything I had learned before. It wasn't that bad at all. So anyway, that's that. Let's do another one. So let's do absolute value. Y equals absolute value. Now this is going to look a little different than what you're going to. It's a little different than what we think of as absolute value. As soon as you see absolute value, what's the first thought as far as graphing is concerned? It's a V, all right? But this is not going to be linear. This is not just a straight line. We're going to do a squared in there. All right, so you're not going to have straight lines when you have something that's being squared. So that's what's kind of fun about Desmos. You can put super complicated stuff on there and it graphs it just like that. You can look at it and say, oh, well, that does this because of this reason. All right, so we got absolute value of, now I'm going to put a parentheses, let's see, x. Now, see, I didn't put a squared yet, so it looks like a v, doesn't it? All right, let's go -2. I'm just going by what I have in my notes there. Now, look at that. So we squared it, but I'm not done yet. -3. Look at that. Why in the world did it do that? Because it's in absolute value, correct? So that means, can we have any negative y values? No. Tell you what, let's do this. Let's put this whole thing in again. But I'm going to put a +3. What do you think that's going to do? Because what was this trying to do? It was trying to put that point down here at -3, wasn't it? But can you have a negative? So what did it do? It made everything that was going to be negative, it made it what? Positive. So it actually flipped it up because of the absolute value. But what if we put a +3 in there? Am I going to have to worry about anything dipping down into the negatives? No. So watch. Oops. Missed it. Hold on. So put a +3. Check that out. Now it kind of looks like a regular parabola, doesn't it? All right. So really, the absolute value, when this does not go below the x-axis, looks just like a regular parabola. There's really no difference. But when you have it go below the x-axis, and that -3 would have gone below the x-axis, wouldn't it? Tell you what, let's do this. Let's copy that. Let's put that here, but let's get rid of the absolute value. And let's get rid of the blue one. Oh, the green one is covering up the red. That's why you only see a little bit of that red one, okay? So remember, that red one, what did it do? It went here, and then instead of going down here, what did it do? All those negative y's became positive y's, and so it flipped up like that. That's probably not a graph I would have thought of. Would it be for you? Probably not. But now you see it, and you're like, yeah, it kind of makes sense now, doesn't it? Because I can't have any negatives when I have everything in the absolute value there. So that's what that would look like. So that's kind of interesting. Let's do one more, and then we'll quit. I'll tell you what, let's just get rid of these. Boom, boom, boom. All right, so let's do this. Y, I'll just do these, equals. We're going to do absolute value again, but this time I'm just putting the x in the absolute value. All right? And then I'm going to go -2. And I should have had a parentheses right there, and a parentheses right there. And then let's square that. Now watch what happens. Look at that. It's crazy. So it comes up, then it goes back down again, and you could always shift it. I put a -3 on there, so it just took everything to the -3. Oops. There we go. See, it comes down here to the -3 and the -3. All right? Again, pretty weird looking graph. Kind of looks like a W. All right? Yeah, because watch, anything from 0, well, let's see, where's that point? I'm not going to say what I was going to say because it's not right. Anyway, it's just interesting to see what these graphs look like. I don't believe you're going to have to graph something like that on your own, okay, by hand. But it's just kind of cool to see what these weird looking graphs look like. Yeah, I think that's about it. So that should help you, I think. That should help you a little bit with those problems that you had to do last night. Again, you don't have to graph them. All you got to do is describe it, okay? If it's a minus inside of a function, it moves to the right. If a plus is outside the function, it moves it up. Okay, if you have a number in front of the x and it's being multiplied, what does that mean? That it kind of squishes it, right? Compresses it. Okay, that's the word we'll use. Compress, and what was the other word they use? Expand, okay? All right, so compresses it, expands it. If you have a number between 0 and 1 is being multiplied, what does that do? It expands it, all right? So you saw visually what it does, so hopefully that'll help you out a little bit on there. Do you think that's going to help you with the homework? Yeah, I think so. Okay. So I think that's it. Let me see. Did I give you anything else on that? I did. I give you 20 to 25 and then 28 to 33. We'll just do the 20 to 25. Is that all right? All right, so let's just do the 20 to 25. Here, I'll write it right here. What was the page number on it? Well, I'll just put this. Section, what was it? 3-2? Oops, it's not letting me type in there like normal. I thought you could just type words in there. But anyway, section 3-2, 20 to 25, okay? All right, that's it.